All right, so we're going to be looking at exponential growth, but we're going to be looking at it in the zombie apocalypse. So here's our first scenario. Zombies have invaded our town and are infecting at an exponential rate. Scenario 1. We have one zombie, and each zombie infects one person. So our time frame is going to be nights. So each night, another zombie is infected, and then the next night, each of those zombies infects as a zombie, or infects a person and becomes more zombies. So we're going to look at how to write that as a function and how to graph that. And then we're going to answer the question, how many zombies will be in 30 days? So let's look at a model. Here we go. We got this. We start off with one zombie, and so this is night 0. So at the beginning, there was one zombie. So it's nighttime. Dun, 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 dun. Next morning, he's infected another zombie or another person. So this is night 1. We've infected one new for a total of 2 zombies. So in night 0, we started with 1. On night 1, there were 2. All right, now, dun, 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 dun. Next night. So we don't just have one more infected. We have both of these 2 zombies that we have infecting 2 new people. So this one infects this guy, but he also infects this guy. So we have 2 new ones, but on night 2, we have a total of 1, 2, 3, 4. All right, so let's keep going. Night 3. Each of these 4 zombies is going to infect another zombie. So he's going to infect a zombie or infect a person. He's going to infect a person. He's going to infect a person. And he is going to infect a person. So now we have 4 new zombies, but we have a total. We had 4. We have 4 more, so now we have 8. Night 3, 8. Let's look at one more night. Now each of these is going to infect another one. So night 4. Blue line from him, blue line from him, blue line from him, blue line from him. Gotta make sure they all get one. 1, 2, 3, 4, 5, 6, 7, 8. 8 new, total of 16. So what's the pattern here? With linear equations, you look at the difference, like +1, +3, or +2, +4, but that's not what's happening here. Most of you are going to say, oh, they're doubling, so this is times 2. This is times 2. This is times 2. So each night it's going up by 2. So in order to model this, we're going to have a y equals, obviously. But it's not 2x because it's not 2 times 0. 2 times 0 does not give me 1. 2 times 1 gives me 2. And it works for these 2, but 2 times 3 does not give me 8. So that can't be it. If it's doubling, we need to be doubling these. So as y goes up by 1, or excuse me, as x goes up by 1, these are doubling. So think about it like this. This is 0 to the 1 power. This is 1. Let's back up. Let's not even go there yet. I want you to look down here. 4 is 2 times 2, right? 2 is 2 times 1. 8 is 2 times 2 times 2. 16 is 2 times 2 times 2 times 2. It is 2 4 times. I wonder if on the 5th night, if it would be 2 times 2 times 2 times 2 times 2, because it would double, right? So this should be 32, because if we double 16, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So how do we write that? So we're taking each of these, and this is 2 5 times, right? This is 2 4 times. So we're taking the number 2, and whatever x is, that's the power we're raising it to. If we were to plot these points, let's look. 0, 1, we start at 1. 1, 2, 2, 4, 4, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is already off of my graph. So maybe I should have thought about counting by something else, huh? Ooh, that is terrible. It's a good thing I have this here. So let's look at this. I want to graph that. Y equals 2 raised to the x. Oops. I want this to be the x. So this is what your graph would look like. But this is not. There we go. It's in halves. There we go. So 0, 1 is a point. We could even take this, and if you're not familiar with Desmos, it does all kinds of cool things. We can make it into a table of values. We'll start at 0, 1, 2, 3, 4, 5, 6, 7, 8. So you can see how high it goes. Look at it doubling each night. All right, so let's go back. Let's look at this question down here at the bottom. How many zombies will there be in 1 month? 30 days. So I need to be looking at my x is 30. So y equals 2 raised to the 30 power. Well, let's see what we find. That's not the calculator I wanted. 2 to the 30th power. Look at that number, 1.07 times 10 to the 9th. So let's look at that, 1.07 times 10 to the 9th. That means add 9 zeros, or 9 decimals places. 1, 2, 3, 4, 5, 6, 8, 9. So I add zeros for all those places. I know there were other numbers, but for the sake of estimating, right, comma, comma, comma. Thousands, millions, billions. So 1 billion. If one person infected one person each day, we'd have 1 billion people infected. How many people, population of the world? 7.5 billion. 1/7 of the world would be infected. So let's look at the population of the U.S. 327 million. More than the number of people in the United States would be infected if one person infected one person each day. Now, we could look at some more examples, but I'm going to skip down for those of you that need a shorter version. And I'm going to show you the equation for exponential growth. All right, so exponential growth is this function. Y equals A times 1 plus R raised to the x power, where A is the initial amount, R is the growth rate, and X is a number of time intervals. So if we look at the problem we just did, Y was actually the number of people infected. A is the initial amount. So in this problem, we started with one person being infected. Now, inside the parentheses, we had a 2 because it was doubling each day. But the growth rate was really how many are infected each day? So each day we infected one more. The growth rate was 100%. It doubled each day. And X is the number of time intervals. So simplifying, in our case, going back, that's the nights. So simplifying this, the equation is Y equals 1 times 1 plus 1, which is 2, raised to the x. And we can rewrite that as simply 2 to the x power. So if that makes sense, you can go ahead and stop me here, but I'm going to do another example for those of you that need to see 1 or 2 more. All right, I'm not going to graph all of these, but we are going to look at the model. So starting with one zombie, each zombie then infects 2 people. So we start with 1 again. On night 0, we have 1. And each night, 2 more people are infected. So let's take a look. What does that look like? So this is night 0, and we have 1 infected. So on night 1, that person is going to infect 2. So we have 2 new zombies for a total of 3. All right, so let's go add that to our table. Night 1, total of 3 zombies. All right. Next night, night 2. Now, each one of these has to infect 2 more. So he's going to get 2 more. He's going to get 2 more. He's going to get 2 more. Grab some zombies. 1, 2. All right. 6 new ones plus the original 3 gives us a total of 9. So the difference in this one, over 2 days. In the first problem, there was 4 in 2 days. There's 9 on this one, and that's infecting 2. All right, next night, each of those is going to infect 2 more. Let's go back and add this to our table, 2 and 9. So each of those is going to infect 2 more. Let's see if I can fit this in here. Night 3. Oh, this is going to be a jumbled mess. 1, 2. All right, so I need 2 here. This guy is going to get 2. This guy is going to get 2. And each of these guys are going to get 2. So 2 for him, 2 for him. 2 for him. 2 for him. Oh boy. 2 for him. And we need 2 more. 2 for him. I hope I didn't miss any. This one. I'm going to draw a line for this guy. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 more. 18 new. So plus the 9 we have 27, y'all. 3 and 27. We have 20, and that's with them infecting 2. So we will look at this equation. I'm not going to plot the points. But you're going to see if you do plot the points, it's going to go up a lot faster. All right, so this is infecting triple the amount each night. But if we look at the equation that we had, we look at this. Let's use this to write our equation. All right, so y is the number infected, and A is the initial amount. So in this one, we still started with 1. And then each night, the growth rate was 2. So we end up with y equals 1, 3 to the x. 3 to the x power. So let's look at what that would look like if we graphed it. Y equals 3 raised power to the x. So there's our graph. And for comparative purposes, I'm going to go back and regraph 2 to the x. So the purple one is the first one we graphed. The green one's the second one we graphed. Look how much steeper that is. Look at a table of values for that one. 0, 1, 2, 3, 4. In 30 days, we would be all the way up 2 times 10 to the 14th. That is way, way more than what we had before. All right, let's go back over here. All right, so that would be your equation for that one, because it's tripling each night. What if each zombie infected 9 people? A, 1 plus r to the x. So assuming that we're still starting with 1, your starting would be A. Your rate would be 9 each day to the x. So you would end up with 10 to the x power. All right, and last but not least, without us having to do all of this, if we started with 2 zombies and each one infected 1, how would that change it? All right, so 0, night 0, we have 2, right? I'm not doing the graphing part. All right, so each of them is going to infect 2. So on night 1, we now have 6 total. Now, look at the next night. Each of them is going to infect 2. So this guy gets 2, this guy gets 2, this guy gets 2, this guy gets 2, this guy, oops, gets 2, and this guy gets 2. 2 for him, 2 for him, 2 for him, 2 down here. So 2, 4, 6, 8, 10, 12. 12 new ones plus the 6 we already had. 18. Look how fast that's increasing. What would this equation look like? Y equals A, 1 plus R. Keep forgetting to write that 1. X. A is the starting amount. Well, this time it's different. We're not starting with 1. We're starting with 2. Our rate is 1 because each one's infecting 1 each night. So our equation is 2 to the X. Look at the difference. I'm going to hide this one. And put that back because I'm take it off of there. All right, so this is that original one we started with. Look how much higher that one is. It doesn't increase faster because it starts at a different place. So it's the same increase. The numbers are higher though because of where it started. If we had y equals, we started with 2, and let's say each one infected 2 more, so it'd be 3 to the x. I just realized why I was doing that. I was using the wrong button. Oh well. Look how much steeper that one is. It starts higher. It's going to infect a lot more people a lot faster. All right, so to recap what we've looked at, we're looking at exponential growth in terms of a zombie apocalypse. Your equation for that looks like this. You need to know where you're starting, how many are being infected each night, and what your night measurement is, or excuse me, your time measurement. In our case, it was nights. And you can develop a model like this to demonstrate how quickly people get infected when they're around or when they're doubling or infecting a certain amount each night. If you have any questions, feel free to post them below.